Hello, this is Robert from Intrinsic Dev. In this video, I will show you how to download and install our Heatmiser NeoHub Driver for RTI. This driver provides full multi-zone thermostat heating control and feedback for up to 16 thermostat zones. Control features include basic temperature setting, increase-decrease via a slider, temperature hold, set the temperature via the same controls, and then set hold duration for up to 8 hours via increase, decrease, or via slider. Hot water boost. This is via preset buttons of 30, 60, or 90 minutes. Standby toggle, frost mode. Program mode, detailed editing of weekly profiles. Holiday mode, set depart date and time and return date and time. And finally, master control commands where you can set hot water boost, standby state, and temperature hold for all zones in the system simultaneously. All of this can be achieved via multiple UI design possibilities that cover all RTI programming style preferences, produce a UI with intuitive user input for full control of their Heatmiser system. We offer a 7-day free trial for our drivers, so if you'd like to test first, you can click download here straight away. Once this time period has elapsed or you just wish to go ahead and purchase, click Buy License Key. Please complete this form. Make sure to include your RTI processor's MAC address here. If unsure of your Mac, you can view it in Integration Designer. Communications, show devices on local network. MAC addresses will be here. Once the form and payment is complete, click Download. This will take you to Dropbox. Make sure to download the integration note here. This is a big 35-pager. There's some fun maths you can do, optional temperature preset buttons, and just general UI tips and tricks. Download and extract the zip folder. This contains an example Apex file showing the full working setup for 3 zones using everything the driver has to offer, and finally the driver file itself. I'm going to briefly show you how to set up a project from scratch, but to show the features in action, I will use the example Apex file. I recommend having a play with this first, adapt it to match the number of zones in your Heatmiser system, change the room names, add more, etc. Run it and decide which features you want to use. Pull apart the UI to see how it's been put together. A lot of the elements are stacked on top of each other as they dynamically appear and disappear depending on variable state. Feel free to copy and paste anything from here into your current projects. Let's open a fresh Integration Designer window and create a new project. First, if required, head to Options, Set Directories, and that can be set here, control drivers. File, New System. Add your processor. We've got an XP3. So we're going to add rooms to match the Heatmiser system. The driver provides a management port web page that is hosted by the processor and available when the system is sent. You can use this to view all the discovered zones after the initial communication with Heatmiser has been established. I'm going to pretend that I don't know how many zones I have set up in my Heatmiser system or what their names are, so I'm going to use this management port web page in a moment. The first, Integration Designer requires that we add at least one room at this stage. I'm just going to add that attic for now. This name can be changed in the workspace area later if it is incorrect. I'm going to add my virtual panel controller, global. This is to represent an iPad or mobile device that can freely move around the property and therefore control all zones dynamically from a single UI. And I'm going to add a KX10S in-wall controller that is fixed to the attic. And select global. On the drivers tab, you'll see there are 3 source options: individual, global, dynamic, and master. The reason these are split and organized like this is so when using RTI's easy drag and drop tag system, it's clear which tag relates to each source instance, whether that's one of the multiple individual zones if you want up to 16 separate UIs, or global master single UI page sets that control all. I'll now go over these in a bit more detail. Individual zone. 16 sources that can be added to separate rooms in the system. These separate room UIs require an individual source instance and are mapped by a single set of tags. You will not need to manually select which Heatmiser zone you're editing in the UI during runtime, as all commands and variables relate to each zone instance, 1 to 16. Global dynamic. Single source global control for all zones from a single instance UI. Drag and drop tags marked with dynamic in caps to a single set of buttons and elements. These variables are then dynamically populated depending on which zone you've selected during driver runtime on the UI by either a stat zone manual 1 to 16 command button or with the stat zone list element, which is filled on driver startup. You can see in the example Apex file, here is that list element. The list is filled with stat zone list variable, dynamic UI. And the command, when you select on an option that appears, is select stat zone via list element for dynamic UI control. When you have selected one of these options, don't forget to add up and down to browse. The selected stat zone can be viewed via the variable stat zone selected. Let's go back to our fresh project. Master next. Single source global master control to apply commands to all discovered Heatmiser zones from a single instance UI. Note that this does not include setting basic temperature across all zones. Sadly, this is not possible, but it does include setting temperature hold, so the temperature and the period for it to be held. Also, standby, hot water boost, and holiday mode. So back to our example. Holiday mode here, master control. Additionally, in this boiler room, example of all the master commands and variables available. Let's add our sources. So currently we have one attic, one individual zone. I want to uncheck global, add device. Now I want global. I've selected global here. I can add the global dynamic UI for my virtual panel. Add device. And a master control, also global. Untick attic because I only want it by virtual panel. Add device. We can close this. Next, we need to head to Heatmiser Neo under drivers and to driver properties. Add the IP address of the Heatmiser Neo. As mentioned earlier, it is now time to visit the management port webpage, as I am unsure of the number of zones I have in my Heatmiser system and what their exact names are. Simply send the system to the processor now. Open a web browser and head to the XP's IP address followed by a colon and the management port number that has been set here. If this port is unavailable or nothing seems to load, then try another port in case there's a conflict in your network. I'm going to leave it as the default. Taking my current target. Here are the IP addresses of your processors. Send. While that's sending, opening a browser. 192.168.10. If the page is loaded, but it still says this site can't be reached, it means that the processor and driver are still loading. So wait a moment and click reload. Here is the management port webpage. Please allow a further moment for the driver to process the discovered zones. Keep hitting refresh until they're all here. This should only take a minute or so, but if this page is loaded and no zones are being displayed at all, then double check the Heatmiser IP address and resend. Here are all my zones. I'm going to head back to Integration Designer now. and use this drop-down to inform the driver of how many zones we have. Copy and paste the names into these fields. Set the desired temperature unit and the gather time. So I'm going to head back to the example Apex file so I can explain the concept behind this gather time. But first I will quickly finish off the setup of our new project here. Now that I know all of the zones in my Heatmiser system, I will properly add them to the workspace. It is important that the order that we copy the zones into driver properties matches our sources in the workspace, so that the correct zones data is displayed and used for commands. If you have already added all of your rooms as you knew the zone names, check the order from the Management Port webpage, and if necessary, remove and re-add the sources so that the numbering is correct. So I now know that Zone 1 is meant to be the garage. I'm going to delete, add new rooms, rack, add room, and our new attic, add room. Quickly add our controllers in, rack, KX10S, attic, new attic has a KX10S. Drivers, make sure you're under add to existing driver. Zone 1 is now garage. Rack is zone 2. Attic is zone 3. Close this. Quickly show you magic of the tag browser. Up and down temperature. Tag browser show Heatmiser NeoHub Driver tags. You can see is the dynamic UI control, UI variables, gauges and sliders. Make sure those are used correctly. Individual zone. There's the master control, master variables. We're interested in individual zone control. So these aren't numbered. It's just one set of tags that applies to all. Let's drag temperature down, temperature up, garage zone 1, and copy these. Paste those there. So you only need to make one panel in zone 1, and then you do a Control A, copy all, and the magic of tag browser, these are now zone 3. Attic, temperature down, zone 3 up, zone 2 down and up. So I'm going to head back to the example Apex file, send that system to the processor, launch the virtual panel, so I can explain the concept behind this gather time. While this is loading, it's a good opportunity to explain the driver ready state variable. The driver initialization period can vary. Displaying this variable will make it clear when the driver and UI is ready for control. So after successful processing of discovered zones is complete, this variable will be set to true and remain as true throughout driver runtime. Here it is here. As this is a dynamic UI, I have to select the zone. I'm going to choose garage. And you see all of these variables have now populated. Gather time. For some commands, the Heatmiser API requires multiple parameters. To achieve this, the driver allows multiple parameters to be set via different UI elements during a gather time period and then sent as a single command. Upon receiving the initial notification that the user wishes to control one of these multiple parameter features, the driver internally starts a countdown timer. When the countdown has elapsed, the driver will send the command with the multiple parameter data gathered to Heatmiser. Specific Boolean state variables are available to show when this gather period is active. Clicking hold. The orange highlight here indicates that the gather period has started. So any second now, when 10 seconds has elapsed, there, it has stopped. This countdown is reset with each new value change, allowing multiple values to be set for a single command, or repeated increase-decrease button pushes for adjusting values. The driver will automatically ignore the command and not send to Heatmiser if any required values have not been set, values have not changed from the initial values, like what we just saw, or if a user error has been made, for example, hold time has been set to 0. So beginning hold, I want to hold it at 27.5 for 3 hours and 10 minutes. Now we're going to wait for that 10-second gather time period to elapse. There. We have confirmation it is holding at 27.5 for 3 hours and 10 minutes. It's worth reading the integration note for full explanation on the behaviors of all of these commands. For example, the hold time can still be adjusted from the current point in the countdown. This puts the variables back into setting state, allowing hold temperature to also now be changed. So I wanted to increase that up to 3 hours and a half, or even 5 hours, make it 6 hours. I could think 27 is too hot. Use my slider, set it to 20.5. I'm going to cancel this and show you the basic temperature control. These commands are being sent instantly. When frost is enabled, Heatmiser does not allow temperatures above 17 degrees Celsius. Clicking above here on the slider has no input, and likewise does not allow inputs below 7 degrees Celsius. Water boost, 30 minutes. Can cancel it here and here. 60 minutes, 90 minutes. And to show changing zones, rack. So it appears that rack is already in standby mode. Attic, 15.1, also in standby mode. Turn attic out of standby. Next, we'll show holiday mode. This mode allows the user to set a start and end date for an extended period of standby mode. This mode also uses the gather timer. The user must press a button assigned with the command holiday away start holiday data gather. This sets the state of the holiday setting holiday variable to true, giving the opportunity for this visual cue to appear. So we are now ready to set some depart dates. You'll see that the driver does not allow the return date to be before the depart and automatically increases. So leaving on the 24th of January at 2:30 and coming back on 2nd of Feb at 3 o'clock. Again, allow 10 seconds after the inputs have been made for the gathered timer to elapse. We have this nice prompt here, starting holiday in 3 days. I can confirm today's the 21st of Jan. If we're to cancel this, it resets back to the current date and time. So I wanted the holiday to start in 1 minute's time. And then come back in February, 2:30. Wait for the 10-second timer to elapse. Holiday mode activated. The driver is calculating how long we are away for. We are away for 16 days. Next, we have profile programming. This section, the driver allows the user to set new or adjust stored 24-hour, 5-day, 2-day, Monday to Friday, and then the weekend, or 7-day profiles, each with either 4 levels or 6 levels for the period. So in order to set one of these programs, we first have to click this green bar. So for example, 24 hours, so this is every day of the week, Monday to Sunday. You click this will show what was previously set. Wanted to adjust this, going to get up at 7, want it to be a bit warmer, and so on. And wait for the 10-second gather timer to finish. And that has been set. 5-day, 2-day. This is the previous settings. You can adjust all of these. These are just random clicks. The gather timer is still continuing. Excuse the random times, they don't make sense. 7-day, a lot of clicking involved here. And all these can be set. You can do it for every single day. Additionally, this was 4 levels. You have 6 levels. Monday 8:30, 1:30, and so on. Set temperatures for each of these. And so on for every day of the week, 6 levels. Change your mind, go back to 4. We can just click Show Stored to show what is currently saved in the Heatmiser Neo. Thanks for watching.